Hello, everyone. So today we're going to do the fundamental theorem of algebra. What this fundamental theorem of algebra says is a polynomial function with n degree that is greater than 0. So 1, 2, 3, 4, 5. Remember, polynomial means integer, positive integer, exponents. Has n complex zeros. Some of the zeros may be repeated. So complex zeros could be real zeros, so meaning hitting the x-axis, or complex meaning they don't hit the x-axis, but there's that change, okay? And there's a possibility of the max amount of zeros, okay? So what makes the function equal to 0? Well, zeros are known as solutions or roots. Real zeros are known as x-intercepts, okay? So you have some vocab there that you can interchange. 0, solutions, x-intercepts. X-intercepts are your real zeros, where some of them might be the complex when we're solving, okay? Now, first thing we're going to do is I want to highlight that this is saying determine the number of possible, okay? Possible doesn't mean that there is exact, okay? Because some of them may repeat in general, but the most number of zeros that could be in that polynomial. So how do I find that? Well, it's just the highest degree. So for A, the highest exponent is 3. So the possible zeros are 3. So keep in mind the possible zeros are the highest exponent. Okay. In B, keep in mind that this is not in standard form, so you need to search or put it in standard form before you look at the highest degree, which in this case is 4. So there are 4 possible zeros. Done with that concept. Let's move on to the next one here. Now we're actually going to determine, and specifically in this case, we are going to determine the real zeros, okay? In the future, you might end up doing all zeros, complex and real, but right now we're just doing real. Now, real, remember, zeros are your x-intercepts. X-intercepts are when y equals 0. So really what we're looking at this is saying what x's make this 0, okay? So some of these we might be able just to visually see. What minus 1 is 0? Well, 1. What plus 4 is 0? -4. Now, sometimes if you get to the idea, wait, how'd you get that? Just like in this one down here, what I might actually do is set this binomial, this 2x minus 1 equal to 0, and then I solve, right? So 2x equals 1 and x equals 1/2. Now, why are these zeros? Well, because if I make this binomial 0, anything times 0 is 0. So I'm looking at these factors and making them equal to 0. So as my conclusion here, if I'm asking for zeros, all I'm asking for is what does x equal? And that would be 1, -4, and 1/2. Okay, oops, x equals. If the question asks for what are the intercepts, now you have to put them in a coordinate pair. You have to say 1, 0, -4, 0, 1/2, 0. Okay, but if it says zeros, you just need that x value. Okay, so down here, right, first of all, look at this, by the way. I want to come back to this. X times x times x is x cubed. And that means the possible zeros are 3 of them, right? And what do you know? We have 3. Okay. Now in this one, let's talk about possible zeros really quick. We have x times x times x squared. Okay. x times x times x squared is x to the fourth. That means there's 4 possible zeros. Does there have to be 4? No, you can have less than 4. And I'll show you where that comes from, okay? So again, we're thinking to ourselves, what makes a 0? Well, what makes x 0? 0. What makes x plus 3 0? -3. What makes x minus 6 0? 6. Okay, so our zeros right now are x equals 0, x equals -3, and x equals 6. Now remember, I just said, I pointed out there could be 4 possible zeros, but yet we only have 3, and that's okay. The reason is because this 6 is twice. Okay, and that makes us 4. And that will come into play later. Okay. Then our next concept with this that we have to go through is, what if we are given the zeros? Now we need to write a polynomial in factored form. Okay, so I'm going to do this a long way. Some of you might be able to look at it differently and be able to do it in your head. Okay, so I'm going to do it the long way. So really, when I say that we have these zeros, I'm saying that x equals 4, x equals -3, x equals -7, and x equals 5, okay? Well, remember before we set our equation equal to 0 and then we solve. So if we were going backwards, we would have to move everything onto one side. So if we were to move this 4 over, we would have x minus 4, right? If we were to move this 3 over, we would have x plus 3, the -3 over, sorry. If we were to move that -7 over, we would have x plus 7. And if we were to have that 5 moved over, we would have x minus 5. And what do you know? We just wrote our polynomial in factored form. So this right here would be f of x, okay, given the zeros. Now, of course, I'm going to trick you up a little bit, right? So let's do something more difficult. What if I had x equals 1/2, x equals 3, and x equals 0? Okay, I'm going to use a little bit more room here. So again, if I start undoing, okay, I actually do not want you to have fractions in your binomial, okay, because otherwise your leading term will not come out correctly. So watch. How would I get rid of the 2 in the denominator? Oh, I multiply it to both sides. Now, how would I get everything on one side? I would subtract 1. See how that worked? So that gives us one of our binomials. I'm going to write it this way and rewrite binomial in order, okay? So for x here, I would move over the 3. And what do you know? X equals 0 just stays how it is. So how would I write that? Well, x equaling 0 just means that x is out front, okay? Just like we did in example 2. How do you make x 0? Well, it's just itself, right? It's 0. And then we have this binomial of 2x minus 1 times x minus 3, and we're done. So in this little lesson here, we learned what the fundamental theorem of algebra is, the number of possible zeros, how to find the real zeros, and how to work backwards given the real zeros and making a polynomial in factored form. All right, let's try some practice with this.